Today, we're going to talk about the integrated circuit packaging. I'm Mark Anthony Garcia, a third-year electrical engineering student of Iloilo Science and Technology University. The first topic that we need to talk about is the IC supply chain. First, from the foundries, then the fabless, then the OSATs, and finally to the IDMs. And the first one is the foundries. The foundries owns the fabs, and the fabs are where the silicon wafers are manufactured. After that, they sell it to the other fabless companies that does the designing. Some of these main foundries are the Taiwan Semiconductor Manufacturing Company or TSMC, United Microelectronics Corporation or UMC, and Global Foundries. And next, it goes to the fabless. The term fabless means that the company designs and sells the hardware and semiconductor chips but does not manufacture the silicon wafers or chips used in its products. Instead, it outsources the fabrication to a manufacturing plant or foundry. Some of these fabless are the Xilinx, Nvidia, and Qualcomm. And next, it goes to the OSATs. The OSATs are the companies that offer third-party IC packaging and test services. These companies provide packaging to the silicon devices that are made by foundries and test devices prior to shipping to the market. It mainly focuses on offering innovative packaging and test solutions for semiconductor companies. Some of these OSATs are the Advanced Semiconductor Engineering Incorporation and Amkor Technology, and last, the JCET. And lastly, it goes to the IDMs, Integrated Device Manufacturers. These are semiconductor companies which designs, manufactures, and sells integrated circuit or IC products. Some of these famous IDMs are the Intel, IBM, and Texas Instruments. And the next topic is the traditional packaging technology that has two subtopics, which are the pin-through-hole and the surface mount technology. Pin-through-hole refers to the mounting scheme used for electronic components that involves the use of leads on the components that are inserted into holes drilled in printed circuit boards or PCB. And there are two types of pin-through-holes. These are the dual inline packaging or DIP and the single inline packaging or SIP. And the other type of the pin-through-hole is the surface mount technology or SMT. This is a method in which the electrical components are mounted directly onto the surface of a printed circuit board or PCB. There are three types of SMT. These are the quad flat package or QFP, pin grid array or PGA, and the ball grid array or BGA. The next topic is the silicon interposer. The silicon interposer is a thin layer between the substrate and dies. The job of silicon interposer is to either spread the signal to a wider pitch or take the connection to a different socket on the board. Now there are two types of interposer. These are the passive and the active interposer. Now, let's move on to the 2.5D and 3D packaging. In 2.5D structure, there's no stacking of dies on dies. Instead, there is side-by-side integration with TSVs and silicon interposer. In 3D structure, interposer and dies are stacked one above another or vertical stacking with memory and logic. And the next topic is the packaging manufacturing process interconnections. It has two subtopics, which are the interconnections technique and the manufacturing process. There are three interconnections technique. First is the wire bond, second is the flip chip, the third is the interposer. And the next subtopic is the manufacturing process. Number 1. ICs are created on the wafer. Number 2. Pads metallized in the chip surface. Number 3. Solder dot deposited on pads. Number 4. Chips are cut. Number 5. Chips flipped and aligned. Number 6, solder remelted to complete connection. Number 7, underfilled using isolating adhesive. The next topic is the wafer and panel packaging, which contains the two subtopics, wafer level packaging or WLP and panel level packaging or PLP. The first one is the wafer level packaging or WLP. This is a technology of packaging in where the die, while it is still on the wafer, protective layers and electrical connections are added to the substrate before dicing. Utilizing WLP technology allows chips to continue to reduce in size, streamlines manufacturing, and provides easier ways to test chip functionality. Next is the panel level packaging or PLP. This is the latest type of level packaging. Although it is still in its developing years, it shows a lot more promise compared to the WLP. So that's the wrap. Thank you.